Um, Thanks for having me. It's a real pleasure to be here. This is my favorite city in the world, no joke, and with some of my favorite people in the world. It's definitely a huge honor to be here. Um, let's talk about myself, my favorite topic. Why am I here? Well, I do several things that are interesting. I have the privilege of working on some of the hardest technological challenges of our time, which is creating human-level artificial intelligence with a focus on media and entertainment as part of Corto AI. It seems the clicker, yes, and we have customers that are large enterprises that we build very high-end AI platforms for, including the US military and increasingly a lot of Hollywood studios. I also I also manage the Data and Analytics project at the Entertainment Technology Center at USC. My research is funded by all the Hollywood studios, and I report to all the CTOs of the studios. And so I'm very privileged to be working, having the freedom of academia and also the accountability of industry, building AI machine learning platforms for Hollywood. And we have all of the studios are members and a bunch of technology companies, and we do a lot of really interesting work, which I will talk about today. Clicker is not, here it is. All right, so media is having a moment, right? We'll see a lot of visibility, a lot of volatility in a lot of phenomena, volatility in film revenue, theatrical revenue is down, ticket sales is down in 2017, volatility in TV ratings with some programs doing extremely well and some programs doing not so well. We see, I'm clicking. This is why we need to take the humans out of it, because this is, if an AI was delivering this talk, this would not be happening. Okay, a lot of volatility in market competition. We'll talk about it a little bit later, but there's an infinite amount of competition for entertainment companies and even news media. Snapchat, Facebook, Twitter, Google are all services and applications that take time away from other types of entertainment, and there's never going to be more than 24 hours in a day. And also volatility and social responsibility is enormous pressure now on the media to be more accountable with regards to fake news and things like that, which we talked about. Whenever there's volatility in a market, it means that this market is very inefficient. It means that the players in the market are not fully understanding the inherent value of the asset, right? And the asset here and the product here is this. Media is the most cognitive product ever created. And it's also, ironically, the media industry is an information industry without a science. Like, who understands the media product? Who really understands the media product? What is the meaning of green? What is the meaning of a certain edit cut, right? And so a lot of the things that I do is applying AI machine learning to solve the complexity around the media product and understand a very simple question. Why did people like this TV show? I mean, it's a very simple question, but it's a very complex answer. So I apply AI machine learning techniques to do that. Let's talk about definitions. They've asked me to really frame the debate around what AI is and AI isn't. It's likely that 99.9% of what you've heard called AI is actually not AI. Two AI researchers called Marcus Hutter and Shane Legg listed 70 different definitions of intelligence. And Shane Legg came up with, in my mind, is the best one, which is the one that he used in his PhD thesis in 2008. AI is the design of optimal behavior of agents in known or unknown computable environments. And the notion of agency here is extremely important. if you're running a convolutional neural net on millions of images, great. It's very difficult. It has high value in some cases. It's not AI. An AI application will have agency in the domain that it's applying it. It will make decisions. I'll give you an example. My company has created a hedge fund that doesn't have any humans in it. It trades on its own and learns from its performance and layers the performance results into the models. That's an AI application. A self-driving car will make decisions in the environment in the computable environment that it is known, and that also is an AI application. If your application is learning from data, probably very highly valuable, but if it doesn't have agency, it's probably not an AI application. All right, so, hold on. All right. Next one. Okay. So this is an overview of what artificial intelligence is. So machine learning is definitely a foundational layer of AI. It is by no means AI. It's like saying that an orange and the color orange are the same thing. They're not. One is the property of the other. And you can look at artificial intelligence at a very high level in these 4 domains and these 12 subdomains, of which machine learning is one domain. But the field of AI, and that's why it's so complex, is extremely complex and multi-dimensional. It has elements of mathematics and computer science and cognitive science and computational neuroscience, and even philosophy. So, which is why there's a lot of confusion around it. So, let's talk about the various dimensions around AI. So, machine learning, as we said, is the ability to learn from data. There's a lot of problems that cannot be solved through traditional if-then statement programming. You can't program a helicopter to fly on its own. You can't program a car to drive on its own. The only way to create an application that autonomously can do that is through machine learning. There's 2 types of AI. There's something called narrow AI, in which the application will have agency in one domain and exhibit intelligence in one domain, but you can't port that application over to other domains. I'll give you an example. A self-driving car is an AI application. It's a narrow AI application. You can't take a self-driving car application and make it trade stocks or even drive a motorcycle. You'd have to completely rewrite it. That's narrow AI. Artificial general intelligence is, on the other hand, one application. I'm clicking. There you go. Is one application that generalizes across domains. Just like the human brain can drive a car, drive a motorcycle, trade stocks, learn a language. And the things that my research is targeting and my company is building is artificial general intelligence applications, and we'll see a few examples later on. So you see there's an element of representing, learning, optimizing. Also, self-reinforcement is a really important one. Maybe I can run it from here. Maybe that'll be a lot easier. Okay. And the field really is going from machine learning to machine understanding, the difference being a machine learning application will have less semantic abilities than a machine understanding application. Why? Why do we talk about AI in media and entertainment? Well, there's 3 reasons. One is because we can, because we should, and because we must. We can because AI is here after 50, 60 years of false starts and disappointments. Finally, AI is a real thing. And it's a real thing because of the combination of an explosion of availability of data, an explosion in the availability of cheap computation, an explosion in the openness of the methods that are out there and for free for everybody, and an explosion or a roar, because it's not really an explosion, this talent is still pretty rare, of talent. We should, that's interesting. Why should we talk about AI in media? As I was mentioning, media is the only information science, information industry without a science. Media creates the most complex and the most fundamental products in our lives, stories. Stories are a set of steps to solve a problem. Guess what else is a set of steps to solve a problem? It's a computer algorithm. Stories are a compression mechanism that help us compress the infinite complexity of the world and the universe that we live in into a set of behavioral steps, which is why stories are at the heart of every single one of our decisions, which is why stories are so important. Stories are basically factor analysis. They're a reasoning tool. They are a cognitive methodology, not just a product. And so you're building a product from a very, very fundamental cognitive process, which I think deserves to be understood. And the only way to understand it is to use machine learning and artificial intelligence. And in the environment where we're trying to understand the relationship between stories and the behavior, look, Trump was a story that worked. Brexit was a story that worked, right? And so there is an emerging societal need to get to the heart of what stories create what type of behavior. And the only way to do it right now is through machine learning. And that's where my research is aimed. This is an algorithmic view of the story for The Godfather. You have 4 dimensions. What is the overall story about? What is the main character about? What is the impact character about, which is the antagonist, generally the antagonist, but not always the antagonist. And what is the relationship story between the main character and the impact character? You see, this is a matrix of values, right? This is a narrative structure view, algorithmic view of The Godfather. We've tagged hundreds of movies to this taxonomy, and we've looked at which narrative structures correlate to the best theatrical performance. One other thing that we're doing, we've developed a mathematical model that explains why everything is interesting. I'll go through it in a little bit, but it basically has to do with, in anything that we find interesting, whether it's a person or a character or a film or a relationship, there's a similar ratio of attributes about that thing that are known to us that allow us to represent that thing cognitively, and a huge layer of novelty. If all the attributes about your film or your brand are all in the expected and traditional domain, you're boring. If all the elements about you, about your brand, about your relationship, about your film, about your story are in the novelty domain, it's overwhelming. People can't represent what the story is about. So there is a mathematical model of interestingness, which we call the theory of everyone, that we're working on. And also we must. Media is a really, really tough market, right? The demand for media is stable. There's never going to be more than 24 hours in a day, but the supply of media is exploding. So you are in a business where the demand is stable and even declining, but the competition is rising and exploding. Right? And that's why we must better understand audiences. We must better understand products. We must better understand why audiences like certain products. So let's talk about applications. At ETC, we focus our work on 3 areas. Semantic audience intelligence, how do we develop more semantic view of audience, which we call audience genomics. Semantic content intelligence, how do we develop more in-depth, more semantic view of content, and we call that content genomics. And semantic operational intelligence, how do we develop a semantic view of our organizations to create efficiency. Audience genomics. So this is the stuff that we're doing. We're mining social media, this is called Contender. We're mining social media to represent the narrative domains of the conversations. We're measuring, when people talk about Al Jazeera, when people talk about Starbucks, what do they talk about? What are they really talking about? What need are they expressing? We extract sentiment across 60 different dimensions, not just positive, negative, neutral, and we also measure how interesting anything or anybody is. And the cool thing about that is that it's accountable, because if you extrapolate qualitative attributes quantitatively, now you can do a lot of magic correlating these quantitative metrics to other quantitative metrics like Nielsen ratings or theatrical performance or sales data. We have a big project right now running with one of the big networks in the US correlating social media conversations and Nielsen ratings. and try to understand what kind of sentiment, what kind of deep semantic social media metrics correlate to certain Nielsen ratings. We're throwing in weather in it, we're throwing traffic in it, we're throwing scripts in it. What kind of emotional tonality of script generates certain reactions in audiences that then generate certain ratings? Like we're doing that right now. And when you do that, then we are able to extrapolate very useful insights, specifically for brands, saying, hey, when the conversation about you is in this social media domain, it is in this narrative domain, you make more money. That's audience genomics. Story Cipher is the study that I was just mentioning. We took 300 movies, we tagged them to dozens of narrative attributes and narrative structure attributes, and we plotted that versus box office returns to know what kind of narrative structure generates the best box office returns. And this is the kind of stuff that we found. The study is going to come out later this year. Snowflake is really interesting. Snowflake is actually coming out in a few weeks. Snowflake is a free tool for independent filmmakers to make very deliberate decisions about their film looks. So if you're an independent filmmaker, you're starting your journey with either some ideas about the kind of look that you want, the kind of visual universe you want to explore, the kind of emotional universe you want to explore. So we have image search to allow you to pull some images from the web and analyze the color schemes of these images. You also have a script. You can upload your script, and we're going to parse your script for dozens of emotional attributes of character. We can give you a plot of a character arc for all characters. Now, we feed this into our database that has thousands of scripts and thousands of movies to be able to tell you, hey, for your budget, in the kind of visual universe and the kind of emotional universe that you want to explore, these are the films that have explored the same emotions, and this is the visual schemes that they've used, and this is the equipment that they've used. So we can run an independent filmmaker from an idea and a script all the way down to the kind of equipments that are used to create specific film looks that they want to have. Now we're taking this to the next level, and this is a more ambitious view of this. Film to Vec is an extrapolation of word to vec for film. Now, my dream is to measure cognitively all aspects of film: color, white balance, edit pace, composition, music, emotional tonality on one end, and measure audiences' cognitive reactions to every single one of these attributes. I want to know what green means. What does it mean? I want to know what purple means to people. What is the cognitive impact of a specific story, of a specific character, of a specific color, of a specific edit pace, of a specific white balance? And Film to Vec is one half of that. With Film to Vec, we're assigning every single dimension of film, every single attribute of video, color, composition, edit pace, music, emotional tonalities, into a numerical vector. Now, machines are terrible at processing nuance the way we're doing it, but they're very, very good at processing numbers. And what we're doing is we're creating numerical vector embedding representations of the nuance. For example, if you say, I love my wife and I love hamburgers, now our brain will automatically understand the different contexts. A computer will have trouble understanding that love means this way, something this way, and something else that way. That's why numerical vector embeddings allow you to represent these different dimensions numerically. And we're doing that across all dimensions of film. And so I want to know what lineup of color and edit pace in white balance, in depth of field, in music, and emotional tonality, how does that translate into something resonated cognitively with audiences? What is the perfect alignment of that creates resonance, cognitive resonance? And so we're doing that for every single attribute. And what we're doing for that is we're creating what we call meaning codes. For every frame, every scene, every movie, we have a meaning code next to the time code. Next to the time code, this is a numerical representation of what happens in this frame, what happens in this scene. And then if you can measure that, and you can measure audience reactions very, very granularly, which we're going to do next year, then something's going to happen. You really got to understand the impact, the cognitive impact of media, which is what we're doing. Operational genomics is really important. We're taking all of these applications, all of these insights, all of these algorithms into a platform called Cordo. And Cordo is a knowledge engine. Cordo is a semantic knowledge engine that can represent data across formats and taxonomies and allow anybody to analyze that data very, very deeply using some machine learning algorithms. That's the second layer. And the beauty about that is that it's all outputted in a natural language interface, and I'll show you how it works. This is a demo of Cordo. So you see, we've represented data across social media, P&L, script data, video data, marketing data, production data, camera data. Everything lives in Cordo and is queryable in natural language. Plot points, how does specific plot points correlate to certain box office returns, et cetera, et cetera, et cetera. It's got a lot of algorithms beyond neural nets. It's got evolutionary pattern mining, probabilistic logic. And so this is very powerful. This is what we're building for Sony Music and NBC Universal and Warner Brothers. I personally think the entire media industry is going to run on this. So you've seen it first here. And the cool thing about it, too, is that it's very didactic and very accountable. You can ask questions about the models. It's not a black box. You can say, hey, how did you come up with these answers? And it's going to retrace all the steps to come up with these answers. We use this data, we applied this algorithm, and we found this. And frankly, it also takes the data science away from the data scientist, which is about time, and puts the analytics in the hands of virtually anybody in your organization, which is why it's very disruptive. And it can also pull some scenes that to optimize trailers. So what are we doing with this? Well, as I mentioned, what we're doing with this is we're trying to understand stories, and stories drive our lives so much, and stories are so important to our societies. It's high time that we develop a very deep, very cognitive view of stories and storytelling. It's high time for our societies, it's high time for our industry, and AI and machine learning can help do that, and this is what we're doing at ETC. Thank you very much. Guess we have time for questions? Yes, sir.
That was terrific, fascinating. Thank you so much. How do you deal with neurodiversity amongst the human subjects who are providing your data? We're not all the same. Humans aren't all the same.
Yeah.
But then also cultural diversity, because presumably not every nation, every culture responds the same way
Absolutely.
to the same cues.
Yeah. Oh, absolutely. That's a really, really good question. We're trying to measure, so first of all, we found in our research that we're actually not that diverse. We're less diverse than we thought, right? So we looked at narrative structures and popularity of narrative structures across different cultures. So we took the same data set of film and we analyzed it per territory, and we found a lot of patterns, right? So we're not as diverse as we think. It's all here, right? But you're right. We're still in the early stages of that. So if we can find some trends in aggregate, I mean, I always tell the studios, if you're spending $9 billion producing movies this year, and I'm terrible. I'm just terrible at my job, and I only make a 10% difference. That is $900 million. If we can make the models even 2% more efficient, we're doing better as an industry. We're doing better as a society. It's very, very important to understand why certain stories generate specific behavior in marketing, in politics, and in all of that. So that's what we're doing. But absolutely, at the end of the day, we'll need to be a lot more granular by culture, but it's a good start. Yes, sir. Oh, there's one in the front right here. I'm very afraid because Dr. Hamid knows what he's talking about.
I was just curious to know, when you're doing the storytelling, I mean, you say you have a movie of 90 minutes, and you're sort of trying to summarize the story. So I noticed that you're getting a lot of the information from visual features, like color and so on and so forth. But there's also a lot that can be, if you're identifying scenes, then there is the audio and the text that you can generate from the audio that could be easier to deal with. I was wondering what's the percentage of the overall story that you're getting from the visual features versus the...
Thanks, it's a good question. We measure everything, right? We measure script, we measure dialogue, we measure the emotional tonality of the character. We can detect certain sentiment based on the waveform of the dialogue, right? Is it high-pitched, is it low-pitched? We measure everything. The point is to measure everything. The point is to measure everything to know how much does the color green account for success in representing this emotion in this kind of genre of movie. This is the kind of answer I want to have.